All right, in this video, we are going to be finding zeros and their multiplicities of a function. So the zeros of a function are going to be the x-intercepts. So the way you find them is each factor, you want your function to be in its factored form, which this one is. It's nice that they've already factored it out for us. So there's three factors here. Each factor that has an x, I'm going to set it equal to 0, not using the exponent, just the x part. So on this first one, my factor is just x. I'll set it to 0. The next one is x minus 4. I'll set it equal to 0. And the last one is x plus 6. And I'll set it equal to 0. And then I'll solve them all for x. So the first one, x equals 0, is already solved. The x minus 4, I need to add the 4 to both sides to get x equals 4. And this last one, I'll subtract the 6 from both sides to get x equals -6. So those are the zeros of the function. In other words, that function is going to have x-intercepts at 0, 4, and -6. Now, the multiplicity is what this number is, the multiplicity of the factor. So this one here, the one that came up as x equals 0, it has multiplicity of 4. The next 0, which is x equals 4, has multiplicity 2. And the last one, since I don't see its exponent, it's automatically a 1, which means it has multiplicity of 1. So what that means about the graph, the multiplicity rules. So you're either an even number or an odd number for your multiplicity. If you are an even number multiplicity, that means that you are what's called tangent to the x-axis, which means that x-intercept is just going to touch the x-axis and go the other way. It's not going to cross all the way through the x-axis. That's odd multiplicity. So in other words, if your multiplicity is odd, then you are going to cross all the way through the x-axis at that intercept. All right, another example, finding the zeros and their multiplicities. So each factor that contains an x, you're going to set equal to 0. So this first factor is just -6. It doesn't have an x, so we don't use that. Here's my 3 factors. So each one I'm going to set equal to 0. So x minus 4 equals 0, x plus 3 equals 0, and x equals 0. And then I'm going to solve them for x. So this one I'll add the 4 to both sides. So I get x equals 4. Here I will subtract the 3 from both sides to get x equals -3. And then the last one's already solved for me. It's just x equals 0. So the first 0, the x equals 4, is going to have multiplicity, and remember where the multiplicity comes from. It's the exponent. So that one will have multiplicity 2. The -3, 0, will have multiplicity 3. And then the last one, the 0 that is 0, will have that multiplicity of 4. All right, on this next example, still doing the same thing. However, this one's not already in its factored form like the previous 2 examples. I need to factor what is inside this parenthesis, that x squared minus 16. So I need to put it in its factored form. So it's going to have two factors. To get this x squared, I'll have to use x times x. And to get that negative 16, this is called a difference of perfect squares. I'm going to have 4 and 4, and your signs are going to be different. So now this is in its factored form, and each one of those factors has that same multiplicity. So now it's in its factored form like my previous two examples were. So once it's in its factored form, that's when you set your factors equal to 0 and solve them for x. So here I'll subtract the 4 from both sides to get x equals -4, and here I'll add the 4 to both sides on this one to get x equals +4. So the zeros are -4 and +4, and they both have multiplicity of 2 because they both had 2 as their exponents. All right, one more example, and this one's also going to need to be factored. It's not going to be in factored form for us. So I've got f of x equals x to the third minus 6x squared minus x plus 6. So this is a different type of factoring than the last one. There's nothing in common with all 4 terms. So this is going to be called factor by grouping. I'm going to put each one of these in groups of 2. Now, just looking at the first group, I noticed that the x cubed and the -6x squared have x squared in common. So I'm going to factor out an x squared from each of these terms. So if I take the x squared out of the first term, out of that x cubed, all I'm left with is an x minus, if I took the x squared out of the next term, all I'm left with is that 6. Now, just like I pulled the x squared out of that first group, I have to pull something out of this next group. So I don't see anything in common like I did in the first group, which means I'm either going to pull out a +1 or a -1, because that's the number that you can divide all other numbers by, +1 and -1. Once I do this, I need to have the same thing in my second parentheses as I did in my first. That's what tells you whether or not you need to pull out a + or -1. If your signs are already the same as the first parenthesis, so a +x and a -6, when I look here, I notice that they're the exact opposite. So I need to change the signs, which means I need to pull out a -1 so that I can divide both of these by -1 and change their signs. So that'll end up being a +x and a -6. The reason that you want these two to be the same is so that now you can pull that out as a common factor. So I'm pulling out the x minus 6 from each side. So, and then putting in parentheses what is left. If I take an x minus 6 out here and an x minus 6 out here, it's going to cancel both of those. So you'll notice now you are left with x squared minus 1. That first factor is all the way done. This x minus 6, I can't factor that anymore. So I'm just going to bring it down. But this next one, I noticed that both of the terms in there are perfect squares. So I'm going to factor that difference of squares. To get x squared, I'll need x and x. To get the -1, I'll need +1 and -1. So now you'll notice that all of these are in complete factored form, which means they're all ready to set equal to 0. So I'll have x minus 6 equals 0, x plus 1 equals 0, and x minus 1 equals 0, and solve them for x. So on that first one, I'll add the 6 to both sides. So I get x equals 6. On this next one, I'll subtract the 1 from both sides to get x equals -1. And the last one, I'll add the 1 to both sides to get x equals +1. So your zeros are 6, -1, and +1. And they all have multiplicity. They all have the same multiplicity because look at all of their exponents. Once you factored it, they all had exponents of 1. So all of their multiplicities are +1. All right, one more for this video. So this is going over the multiplicity rules again and what that tells you about the graph and what's happening at the x-axis. The multiplicities are the outside exponents. So this one has a 4 and that one has a 7. If your multiplicity is odd, you are going to cross the x-axis at that 0 or x-intercept. If your multiplicity is even, then you're going to be tangent to the x-axis at that 0 or x-intercept. So this says my function is p of x equals x minus 9 to the 4th times x plus 7 to the 7th. So let's see where these x-intercepts are by setting each of those equal to 0. Solving them for x. So I'm going to add the 9s here to get x equals 9. And here I'll subtract 7 to get x equals -7. So what you are finding is where the x-intercepts are. So this first one, where x equals 9, it's going to be an x-intercept at 9, 0, because if you're an x-intercept, your y is always 0. This one will be at -7, 0. So this is the one they're talking about. It's saying it crosses the x-axis at 9, 0. Well, what was this factor's multiplicity? This number, that outside exponent, was a 4. So it had multiplicity of 4, which is even. What does even tell you about your x-intercept? That it's tangent. So this would be false because it doesn't cross the x-axis at 9, 0. It's tangent to the x-axis at 9, 0.